The transformation of flour into dough is one of the most fascinating and nutritionally consequential processes in cooking. What begins as a simple mix of flour and water becomes a living system during kneading, resting, and fermentation, with structural, biochemical, and nutritional changes that shape both digestibility and flavor. From a positive analytical perspective, understanding these transformations shows that small shifts in preparation, not just ingredient choice, can significantly influence the nutritional value of everyday foods like bread, pizza dough, pasta, or flatbreads. Kneading is the first critical stage in dough development. Physically, kneading aligns proteins in the flour, particularly glutenin and gliadin, into a cohesive gluten network. This network traps gas produced during fermentation, creating structure, chewiness, and elasticity. From a nutritional standpoint, well-developed gluten enhances digestibility by supporting even hydration and starch gelatinization during baking or cooking. Proper kneading also distributes water, enzymes, and other ingredients throughout the dough, ensuring more uniform enzymatic activity. Enzymes such as amylases begin breaking down starch into simpler sugars that yeast or lactic acid bacteria can metabolize during fermentation, setting the stage for a gradual release of glucose in the body rather than a rapid spike. Resting or autolyse is equally transformative. Allowing dough to rest without active kneading gives proteins and starches time to hydrate fully, making the gluten network more extensible and less prone to tearing. Enzymatic activity continues during this period, breaking down complex carbohydrates into simpler forms that are more readily metabolized. In whole grain doughs, resting also permits phytase enzymes present in the flour to reduce phytic acid content, freeing bound minerals such as iron, zinc, and magnesium. Longer resting times, even without fermentation, can improve both the texture and bioavailability of nutrients, particularly in high-fiber flours. Fermentation introduces microbial activity, which further amplifies nutritional benefits. In yeast-based fermentation, Saccharomyces cerevisiae metabolizes sugars to produce carbon dioxide and ethanol, but it also liberates certain B vitamins and enhances mineral availability. In sourdough or long-fermented doughs, lactic acid bacteria create an acidic environment that partially hydrolyzes phytic acid, enhances protein digestibility, and can reduce FODMAP content, improving gastrointestinal tolerance. Carbohydrate breakdown during fermentation produces organic acids that slow starch digestion in the gut, resulting in a lower glycemic response. Fermentation also contributes flavor, aroma, and aroma complexity, making nutrient-rich whole grain or minimally processed flours more palatable, which indirectly encourages consumption and improves overall nutrient intake. Experimental home recipes vividly demonstrate how resting and fermentation times alter both taste and nutritional impact. For instance, a basic whole wheat bread dough can be prepared in 3 variations: no rest, short rest, 30 to 60 minutes, and long fermentation, 12 to 16 hours. The immediate baked dough produces a dense loaf with modest flavor and less digestible starch, whereas the short rest dough develops a slightly lighter crumb and improved chewiness. The long fermentation dough, however, yields a softer, more open crumb, tangy flavor from organic acids, reduced phytic acid, and a more gradual glycemic response. Similar experiments with pizza dough or flatbreads reveal that even a few hours of rest or overnight refrigeration can transform both texture and digestibility. Cold retardation, refrigerating dough overnight, slows yeast metabolism while allowing enzymatic activity to continue, producing more resistant starch, improved mineral availability, and richer flavor development. In addition to texture and nutrient benefits, fermentation and resting can improve satiety and metabolic response. Bread made from long-fermented dough tends to be more satisfying, in part because of slower carbohydrate absorption and higher fiber utilization. For individuals sensitive to blood sugar fluctuations, long fermentation bread offers a subtle, yet meaningful metabolic advantage. Enzymatic breakdown of complex carbohydrates into simpler, yet slowly digestible forms also reduces gastrointestinal discomfort in some people, demonstrating that patience in preparation translates into tangible health outcomes. Beyond these biochemical advantages, the process is empowering for home cooks and bakers. By manipulating kneading time, rest, and fermentation duration, one can tailor both taste and nutrition to individual preference or dietary needs. Short fermentation doughs are convenient and still provide basic structural and digestibility benefits. Longer fermented doughs require planning but deliver enhanced mineral availability, reduced anti-nutrients, and a more complex flavor profile that encourages consumption of whole grains and nutrient-dense flours. The tactile and sensory aspects of kneading and resting also connect cooks to the biochemical transformations occurring in the dough, fostering appreciation for the hidden science of everyday foods. Ultimately, from flour to dough, the interplay of mechanical work, enzymatic activity, and microbial fermentation illustrates that preparation is as critical as ingredient selection. Kneading develops structure and starch accessibility, resting promotes hydration and enzymatic mineral release, and fermentation enhances digestibility, flavor, and glycemic stability. Small adjustments, whether adding minutes of rest, choosing a longer fermentation, or experimenting with cold retardation, translate into measurable nutritional gains while producing more enjoyable, texturally satisfying foods. This approach reframes bread and other dough-based foods from simple carbohydrate carriers into functional, nutrient-enhanced staples, demonstrating that thoughtful cooking techniques are a powerful lever for health and culinary satisfaction.